Hello student, today we will discuss about to derive the formula by using dimensional analysis. Now to derive this formula, we will discuss some questions. First, the time period of simple pendulum depends upon mass, length of the pendulum, gravity acceleration. Obtain dimensionally an expression for time period. Now in this type of questions, the time period depends upon length. So we write length power A. Second, it depends upon mass. We write mass power B. Third, it depends upon gravity acceleration. So we write G power C. Now on combining, we get T directly proportional to L power A, M power B, G power C. Now put dimension on both the sides. The dimension of time period is T. Dimension of length is L. Dimension of mass is M. Dimension of gravity acceleration is LT minus 2 power C. Now this we can write T equal to L power A, M power B, L power C, T power minus 2C. Now there are two terms of L power A, L power C. So we add the power of L. So T equal to L power A plus C, M power B, and T power minus 2C. Now T equal to L power A plus C था, M power B, T power minus 2C. Now on left hand side there is no term of mass and length. So we write M power 0, L power 0 into T equal to M power B, L power A plus C, T power minus 2C. Now equating the power. The power of mass is 0 and here the power of B mass is B. So B equal to 0. Second, the power of length is 0 and on the right hand side the power of length is A plus C. So A plus C equal to 0. In third term the power of T is minus 2C and this side the power of T is 1. So minus 2C equal to 1. So the value of C equal to minus 1 by 2. And we put the value of C in this equation, second equation. So A minus half equal to 0. This implies A equal to half. The value of A is half, B 0 and C minus half. Now put these values in this equation, first equation. Put the value of these values in equation T equal to T proportional to L power A, M power B, G power C. So we get T proportional to M power 0, L power 1 by 2, G power minus 1 by 2. M power 0 is 1. So T proportional to L power half, G power minus half. And this we can write T proportional to L power half upon G power half. And this also can be written as root L upon G. This implies T equal to K root L upon G. This is the dimensional formula for time period. T equal to root L upon J. Now we will discuss second problem. The velocity of sound through a medium depend on density and modulus of elasticity. Obtain an expression for velocity of sound. The velocity of sound V depend upon density power A, modulus of elasticity power B. Now V equal to constant K into D power A into E power B. Equation first. The dimension of D density is ml minus 3 and dimension of modulus of elasticity is equal to stress upon strain. Formula is stress upon strain. The dimension of stress is ml minus 1 t minus 2 and strain have no dimension. So the dimension of elasticity ml minus 1 t minus 2. Now we put dimension of v, d and e. On the left hand side we write lt minus 1. On the right hand side in place of density we write ml minus 3 power a modulus of elasticity ml minus 1 t minus 2 power b. Now open the bracket, m power a, l power minus 3a, m power b, l power minus b, t power minus 2b. b का हमने m की पावर मल्टीप्लाई कर दिया बाई m, l और t. Now there are two terms of m, so we add the power of m power a plus b. Now there are two terms of l and we add minus 3a plus minus b and t power minus 2b. And this side l t minus 1 and we write m power 0. Now equating the power, a plus b equal to 0. Second equation. Now second, l power 1 on the left hand side and l power minus 3a minus b on the right hand side. So minus 3a minus b equal to 1. Equation third. Now t power minus 1 on the left hand side and t power minus 2b on the right hand side. So we write minus 2b equal to minus 1. So this implies b equal to 1 by 2. Now we put the value of b in second equation. Put b in equation second. Then we get a plus half equal to 0. A plus half equal to 0. So value of a equal to minus half. So the value of a is minus half or b is plus half. Now we put the value of a and b in equation 1. b equal to k d power a e power b. So v equal to k d power a minus half e power plus half. So we get k and this shift d power minus half into denominator. So the value of e power half upon d power half. And this we also can write v equal to k under root e upon d. This is the formula for velocity of sound in a medium. The velocity of sound through a medium is given by v equal to under root E upon D. Now come to third problem. The frequency of a stretch string depend on length. So we start the solution. The frequency depend upon length L power E. Second, the frequency depends upon mass per unit length power B. Third, the frequency depends upon tension power C. Now on combining, we get mu proportional to L power A, M power B, T power C. This is the equation 1. Now put the dimension of frequency L, M and T. The dimension of frequency is T minus 1 equal to dimension of length is L power A. Dimension of mass is M, so M power B. Now this is a mass per unit length. So we write M upon L power B. And this T is the tension. Tension is the force. And the dimension of force is ml T minus 2 power C. So this we write T power minus 1, L power A, M power B, L power minus B, M power C, L power C, T power minus 2C. Now we shift this L in numerator, so ml minus 1 power B, so we write this. Now we add the power of same terms. So m power B and m power C, that is equal to m power B plus C. So T power minus 1 equal to m power B plus C. Now L power A, and in this L power minus 1 and L power C. So L power A minus B plus C. Now come to third term T power minus 2C. Only there is one term of the T. So this we write T power minus 2C. Now on the left hand side there is only one term, T power minus 1. So we write M power 0, L power 0, T power minus 1. So यहाँ M power B plus C, L power A minus B plus C, T power minus 2C. Equating power on both sides. On both sides, so we get B plus C equal to 0. A minus B plus C equal to 0. And this minus 2C equal to minus 1. So this implies C equal to half. So value of C equal to half 1 by 2. Now we put C in this equation. So B plus half equal to 0. This implies B equal to minus half. Now we put the value of B and C in this equation. So you can mention the number of equation 2, 3, 4. So A minus half plus half equal to 0. This implies A plus half equal to 0. So A plus half 1. So the value of A equal to minus 1. Now we put these dimensions in the given equation T equal to K. Equation है L power A, M power B, T power C. L power A, M power B, T power C. So that frequency, and on the left hand side this is the frequency. So we write here frequency. Frequency is nu. So nu equal to k L power minus 1 m power minus half t power plus half. So we get the formula nu equal to k upon L, and this t power half upon m power half, and this we also can write nu equal to k upon L under root t upon m. So the formula for time period is, now we write this formula this side. So time, so frequency equal to k upon L under root t by m. This is the formula for frequency in a stretched wire. Now come to next one. The time period of oscillating drop depend upon radius. So we write time period depend upon r power a, density power b, surface tension power c. On combining, we get t proportional to r power a, d power b, s power c. So this implies t equal to constant k, r power a, d power b, s power c. Now we put the dimension. The dimension of time period is t equal to radius L. So we write power a, density m L minus 3 and power b, surface tension m t minus 2 power c, because surface tension is, so we write surface tension S equal to force upon my length, and this force m L t minus 2 upon my L, and this cancel, so dimension is m t minus 2. So sub dimension of surface tension is m t minus 2. Now we open the bracket, so we write L power A, m power B, L power minus 3b, m power c, t power minus 2c, and this is t. Now we add the power of same term, m power b, and this m power c, so we write m power b plus c, L power a, and this is minus 3b, so we write a power minus 3b, and this t power minus 2c. And on the left hand side there is only one term t, so we write m power 0, L power 0, and t power 1. Now equating the power, so b plus c equal to 0. So we write b plus c equal to 0. Equation second. Now second, a minus 3b equal to 0. A minus 3b equal to 0. Equation third. And this at t power minus 2c, or this at t power 1. So minus 2c equal to 1. So this implies c equal to minus half. Now we put the value of c in equation 2. So b minus half equal to 0. This implies b equal to half. And we put the value of b in equation third. Put b in equation third. So we get a minus 3 into half equal to 0. This implies a minus 3 by 2 equal to 0. So the value of a equal to 3 by 2. So a is 3 by 2, b half, or c minus half. Now we put these values in equation equation t proportional to r power a, d power b, or s power c, or either in this equation. So T proportional to R power A, D power B, or S power C. R power A, density power B, surface tension power C. So this is proportional to R power A. A is 3 by 2. D is 1 by 2. And S minus half. Now we shift S power minus half in denominator. So this S3 D power half upon S power minus half. This is T. So all the term contain power half. So this we can write under root S power 3 into D upon, so this become positive, right? When we shift S in denominator, then this becomes positive, and in numerator this is the R power 3 upon my S. So this is the expression for time period of the oscillating drop in liquid. So this time period is given by T equal proportional to R power 3 D upon my S. Student, I think the problem आपको clear हुई होंगी. Important problems है for the exam point of view. Now in next video we will discuss some more questions on the basis of this dimensional formula. तब तक के लिए आप खुश रहें, सुखी रहें.